All right. We're diving deep today into CPPs.
Controllable pitch propellers.
Yeah, those. Pretty amazing tech when you think about it. We've got some really cool material here that I think will help us understand how they work. I mean, the idea that you can change the angle of the blades on a propeller.
It's pretty wild.
Yeah, it is wild.
Like, most people just think of propellers as like one big solid piece.
Yeah, you just see them spinning and they're pushing the boat through the water. But with a CPP...
It's more like you've got gears for your ship.
Like on a bike. I get it, yeah. So you're saying CPPs can shift gears for the ship.
Yeah.
How does that work exactly?
So think about shifting gears on a bike.
Okay.
Uphill, you need a lower gear for more power.
Right.
And then downhill.
You can speed up, shift to a higher gear.
Exactly. CPPs let ships do the same thing.
Oh, I see. So instead of changing the engine speed...
You change the angle of the propeller blades.
Oh, that's so cool.
Uh-huh.
So how does it actually work? Like, how does changing the blade angle...
Change the ship's speed.
Yeah, and even let it go in reverse.
So imagine a screw.
Okay, a screw.
The angle of its threads determines how effectively it digs into the wood.
Right, the steeper the angle.
The faster it goes in.
I see.
Now imagine being able to adjust that angle on the fly.
That's a CPP.
That's the basic idea.
So the blades are like the threads of a screw.
Kind of. The blades are mounted on these things called spindles, and a hydraulic system rotates those spindles.
Okay.
And that changes the blade angle, which we call the pitch.
So the blades aren't fixed. They can move.
Exactly. That's what gives them such a big advantage over fixed pitch propellers.
So what are the main parts of a CPP?
Well, you've got the hub at the center. That's the heart of it all. The blades are attached to the hub, and each blade is mounted on a spindle.
Okay.
And those spindles are connected to a hydraulic cylinder. That's what controls the angle of the blade.
Wow, so it's a pretty complex system.
It is. But it's really clever engineering. We've actually got a diagram in the source material that shows this really well. It's called blade section and variation of pitch with section. It basically shows how the pitch of the blade,
The angle.
right, the angle can actually change along the length of the blade.
Hold on. It's not one angle for the whole blade.
Nope, it varies.
Why would they do that?
Different parts of the blade need to do different things. The part closer to the hub needs to grab the water more, especially when the ship is starting from a standstill.
To get it moving.
Exactly. Then as you move further out along the blade,
The angle changes.
to optimize thrust and efficiency.
So they can curve.
Yeah, a carefully designed curve to maximize the blade's performance.
That's incredible. So by changing the pitch along the blade, they're fine-tuning the propeller for different situations.
Exactly.
So that's what sets CPPs apart from fixed-pitch propellers.
You got it. With a CPP, you've got flexibility and control.
That you just don't get with fixed blades.
Right. CPPs are much more adaptable to changing conditions.
Wow. I'm starting to see how powerful these CPPs are. But if they're so great, why don't all ships use them? What's the catch?
Well, there are a few trade-offs. We'll dive into those in the next part of our deep dive. Well, like any technology, there's always a balance.
Yeah.
Pros and cons.
So what are the upsides of CPPs?
Maneuverability for sure.
Okay, so like how...
Think about a ship trying to dock
Okay.
in a tight space, like a harbor.
Yeah, lots of other boats. Got to be careful.
Exactly. And with a CPP, you can move the ship forward and backward.
Without reversing the engine
Yep, just change the blade angle.
to redirect the force.
Right.
So no need for a big clunky gearbox.
Exactly. Fixed pitch propellers need
So
those.
CPPs are more efficient,
Way more efficient, especially in reverse.
which is important for docking.
Huge for docking and maneuvering in tight spots.
So it's like instant reverse.
Kind of, yeah, you have much more control.
But then how do you actually stop the ship?
Good question. You basically adjust the pitch of the blades.
To create a braking force
Yep. It's a much smoother and more controlled stop.
than just letting it coast.
Exactly. Much more controlled.
Wow, so CPPs are all about control.
Precision control. Yeah,
And that applies to speed too, right?
absolutely. You can change the ship's speed without changing the engine speed.
Oh wow, how does that work?
By adjusting the pitch of the blades, you can fine-tune the amount of thrust they generate.
So you can slow the ship down without slowing down the engine.
Exactly. And that's a big advantage for ships that use their main engine to generate electricity.
Shaft-driven generators.
Yep. They need a constant engine speed to maintain a stable electrical output.
Oh, I see. So with a CPP, they can slow down without dimming the lights.
Exactly. Or shutting down any other essential systems.
That's pretty amazing.
It is a very clever system.
Okay, so we've talked about the good stuff. maneuverability, efficiency, control.
Right, upsides.
But you said there were trade-offs?
Yeah, no technology is perfect.
So what are the downsides of CPPs?
The main one is complexity. They've got a lot more moving parts than fixed pitch propellers.
Makes sense. I guess more things can go wrong.
Exactly, and that means higher maintenance costs.
So it's like choosing between a basic car and a fancy sports car.
Great analogy. The sports car might be more fun to drive.
But it's going to cost you more to maintain.
And you need a specialist mechanic to fix it.
Right. So CPPs are like the sports cars of the propeller world.
Exactly. They're high performance, but they come with a higher price tag.
Okay, what else?
Some mechanism inside the hub, the part that controls the pitch of the blades.
Yeah.
That adds bulk.
So CPPs are bigger than fixed pitch propellers.
Generally, yes.
And that can be a problem for some ships.
Right. If space is limited, it might not be feasible to install a CPP.
So there are some drawbacks.
Cost, maintenance, size.
But the benefits seem pretty significant.
Especially for certain types of ships.
So what kinds of ships really need CPPs?
You're going to find CPPs on ships that really need to be maneuverable and have precise speed control. Things like tugs, trawlers, ferries, even icebreakers and warships.
Okay, I can see how those ships would all benefit. But in different ways, right? Like, why is a CPP so important for a tugboat?
Well, their job is all about precision. They're nudging and pulling other ships, often in really tight spaces.
So they need that fine-tuned control.
Exactly. Imagine trying to dock a huge cargo ship.
In a tiny little harbor.
Exactly. You need incredible control over speed and direction.
So the tugboat captain can make those minute adjustments.
Right, and a CPP gives them that ability.
What about trawlers? I wouldn't think they need to be quite so maneuverable.
True, but they need a different kind of precision.
Okay, how so?
They have to maintain a very specific speed while they're trawling, dragging their nets.
Too fast and they could damage the net.
Right, and too slow and the fish might escape.
So it's a balancing act.
Exactly. And a CPP lets them fine-tune their speed without affecting the engine speed.
Which is important for those shaft-driven generators.
Right, they can keep the lights on and everything running smoothly while still maintaining the perfect trawling speed.
Okay, what about ferries? I feel like they're always zipping around in pretty crowded areas.
Yeah, they're constantly dodging obstacles.
Other boats, piers, swimmers even.
And CPPs give them that quick response time they need to navigate those busy waterways.
So it's like having a sports car engine in a big ferry boat.
Kinda, yeah. They need that agility to be safe and efficient. Now, icebreakers, on the other hand, they're all about power.
Yeah, those things are beasts.
They need that raw power to break through the ice.
But they need control, too.
Absolutely. They need to be able to maneuver in those icy waters.
So it's not just about brute force. It's about being able to apply that force in a controlled way.
Exactly. A CPP gives them the best of both worlds.
And finally, warships.
Those are the ultimate test of maneuverability and speed.
Yeah, in a combat situation, I bet every second counts.
Exactly. They need to be able to accelerate quickly, change direction on a dime, evade enemy fire.
So a CPP is essential for modern naval warfare.
I'd say so. Yeah, it gives them a huge tactical advantage.
Well, it sounds like CPPs are pretty amazing. They're more complex and expensive than fixed-pitch propellers, but for certain ships, the benefits are just too great to ignore.
I think that's a great way to put it.
So it seems like a relatively small design change.
It can have a massive impact on a ship's capabilities.
Well, that's all the time we have for today. Hopefully you've learned a thing or two about CPPs.
Fascinating technology.
It is. And if you want to dive even deeper, check out the source material we used for this episode. And as always, we'd love to hear your thoughts. Connect with us on social media and let us know what you think. Until next time, keep exploring and keep learning.